Continuing with the review, I did realize that I forgot to state which intervals that f of x is greater than 0, or on which intervals, and where f of x is less than 0. So let me go ahead and do that for number 7. F of x is greater than 0 where the graph is above the x-axis. So we have here as well as here. Now, when I write the intervals, I'm going to write x values. So from an x of -3 to an x of +3, the graph is above the x-axis, or f of x is greater than 0. So I'm going to say from -3 to 3. I use parentheses because I do not want to include -3 or 3. That is where f of x is equal to 0. Also from 3 to infinity, because the graph is going to be again above the x-axis from 3 and on. We've got an arrow here. So I say from 3 to infinity. Again, I do need to split this up into 2 intervals because when x is 3, f of x is equal to 0, not greater than 0. And then over here is when f of x is less than 0. So that's from -infinity until -3. So -infinity to -3. So sorry, I forgot that in my previous video. All right, moving on to the next problem, number 9. We want to solve this polynomial equation, and I can factor by grouping for this one. So let's see how that works. So in group 1, the GCF is x squared, and I'm left with x plus 2. In group 2, if I pull out a -9, I'm again left with the binomial x plus 2. So my factors are x plus 2 and x squared minus 9. But x squared minus 9 can factor further. It factors as x minus 3, x plus 3. And then by our zero product property, I am able to set those factors equal to 0. Because if this product equals 0, then one of these factors must be 0. And so our 3 solutions are -2, if I would solve that, 3, and -3. Number 10 is similar to number 9, but I cannot factor by grouping. If I attempt to factor by grouping, it's going to fail. So let me show you if I tried to factor by grouping, what would happen. So I could pull out an x squared from group 1. I'm left with x minus 11. From group 2, the GCF is just a 1. There's not another factor that those two share in common. So I am unable to factor by grouping. If factoring by grouping is going to work, these binomials have to be the same, and they're not. So I need to come up with a different method. So the other method that is discussed in section 4.4 is using the rational zeros theorem. So we put factors of the constant on top, and we put factors of the leading coefficient on the bottom. Factors of negative 33 are, and this is when we use the plus or minus symbol a ton here. Since our leading coefficient is a 1, maybe I'll just start with, because whatever we get is the factors of negative 33. When we put them over 1, we're just going to get the same thing. So our potential rational zeros are plus or minus 1, 3, 11, and 33. Now we need to find one rational zero, and then we're going to be able to use synthetic division to finish the problem to find the remaining 2 zeros or solutions to this equation. So first I'm going to test negative 1. So I'm going to test negative 1 into that equation, and I'm going to see if it equals 0. If it equals 0, that's good. It means it is a solution to this equation. So I'm just going to use my calculator. I'm going to get negative 1 there for that first term, and then it's going to be minus 11 because I would square first and then multiply times negative 11. And then minus 35 minus 33. Okay, definitely not 0. I'm getting negative 80. So negative 1 is not a solution. Let me try positive 1. So this time I'm going to get 1 minus 11 plus 35 minus 33. So I get negative 8. Okay, not a solution. Maybe I'll try, let's try 3. I think that might be the one that works. So I am plugging 3 into the equation for x. And let's see, so it'd be 27 minus 11 times 9 plus 35 times 3 minus 33. Yep, there we go. So I get 0. So one of my solutions is 3. Now I'm going to find the other 2. And I say the other 2 because that was a cubic equation. So I am expecting 3 solutions. So to finish and find the other 2, I put the solution I found in a box. And then I'm going to write the coefficients of the original equation at the top. Okay, so if you look back to the original equation, it was x cubed minus 11x squared plus 35x minus 33. So that's where I'm getting those numbers. I'm going to drop down the 1, and then it's just a series of multiplying and then adding down. I get a remainder of 0, which is awesome. I need a remainder of 0. Okay, so this is good. If you don't get a remainder of 0, it means that the number that you think is a solution isn't truly a solution. Okay, or perhaps you made a silly math error as well. Here's my constant or number term. Here's my coefficient of x. Here's my coefficient of x squared. And if I solve this quadratic equation, I will have the remaining 2 solutions. So x equals, this does not factor, so I'm going to have to use the quadratic formula. I just need a ton more room, don't I, here? Just keep moving these problems down, down, down. So my A, B, and C, up here I've labeled this x squared x and the constant, but those also happen to be my A, B, and C in the quadratic formula. So maybe I'll delete this here and just say this is my A, this is my B, and this is my C for the quadratic formula. So x equals positive 8 plus or minus the square root of negative 8 squared minus 4 times 1 times 11 all over 2 times 1. This would be 8 plus or minus the square root of 64 minus 44 all over 2, which is 8 plus or minus square root 20 over 2. Now we are going to simplify this further. Square root 20 simplifies to 2 square root 5. And then I am able to reduce all of my numbers here on the outside. They're all divisible by 2. And so I get 4 plus or minus square root 5. So my other two solutions to this equation are irrational. So let's see, we found that 3 was a solution, and then we just found that 4 minus square root 5 and 4 plus square root 5 are the other two solutions. So 3 is known as the rational solution, and then the other two are the irrational solutions. Okay, number 11, we have a rational function here, and we want to identify any holes as well as give the vertical and horizontal asymptotes. First thing I'm going to do is I'm going to reduce, if possible, I should say. The numerator has a GCF of 4, and in the denominator, I can find two numbers that add to 7 and multiply to negative 18. Those two numbers are positive 9 and negative 2. So I am able to reduce the function down to 4 over x plus 9. In WebAssign, it is first going to ask for the asymptote. So I guess we'll do those first, then we'll talk about the whole. So there is a vertical asymptote. To find the vertical asymptote, you set the denominator of the reduced function equal to 0. So my vertical asymptote is x equals negative 9. Don't just write negative 9. This is the equation of a line, a vertical line. So x equals negative 9. The horizontal asymptote is found by looking at the degree of the numerator and the denominator. I'm going to use the original function, but if you use the reduced function, you would still get the right answer. So up to you. The degree of the numerator of the original function is a 1. Since we have an x to the first power. The degree of the denominator is a 2 because the largest exponent in the denominator is a 2. What this means is y equals 0 is our horizontal asymptote. There are 3 cases, and this is the case where the degree of the numerator is smaller than the degree of the denominator. And if that's the case, then y equals 0 is our horizontal asymptote. Okay, finally the hole. There is a hole, and the x-coordinate of the hole is 2. We find that x-coordinate by determining what value of x would make that canceled factor equal to 0. So it's the canceled factor set equal to 0 is how I'm finding that 2. All right, the y-coordinate is found by, sorry, now I'm ended up erasing some of it. The y-coordinate is found by plugging 2 into the reduced function. It does have to be plugged into the reduced function. If you try to plug it into the original function, you're going to get 0 divided by 0. So it's got to be plugged into the reduced function. And when I plug it into the reduced function, I get 4 over 11. So my whole is the point 2 comma 4/11. All right, let's do this now with number 12. So number 12 is factored for us, but it hasn't been reduced yet. So let's reduce that. I am able to cancel a common factor of x plus 1. So my reduced function is 4 times the quantity x minus 7 over x minus 2. Vertical asymptote, we set the denominator of the reduced function equal to 0. My vertical asymptote is x equals 2. Horizontal asymptote, this time maybe I'll use the reduced function because you can use either the reduced function or the original function. So I'm going to go ahead and distribute the 4 because I think it's going to be easier to talk about it by distributing the 4. So this time our degree is the same for the numerator and the denominator. The degree of the numerator is a 1 and the degree of the denominator is also a 1. When they have the same degree, you use the equation y equals the ratio of leading coefficients. So y equals 4 is going to be our horizontal asymptote. The leading coefficient in the numerator is a 4, and the leading coefficient in the denominator is a 1, since there's nothing there. Oh man, of course, when I move that down, my work goes down too. Okay, lastly, our whole. Okay, so I had y equals 4 over 1 and y equals 4. Okay, I'm going to copy that and then erase. So our whole, the x-coordinate of our whole is going to be at -1. Remember that to find the whole, we look for the canceled factor. In this case, the canceled factor was x plus 1. And so our x-coordinate is going to be a -1. You have to figure out what would make that factor equal to 0, or in other words, just set it to 0 if you want to find it that way. Then to find the y-coordinate of the whole, I'm going to plug that number, that x-coordinate, into my reduced function. In the numerator, I get -32, and in the denominator, I get -3. A negative divided by a negative is a positive. So here is my whole. In number 13, we want to sketch this rational function. And on the exam, this is going to just be multiple choice in WebAssign. But if you want full credit, you do have to support your answer. So just make sure you support your answer. This one right here, it has no holes because I am not able to reduce that function. If I tried to find the x-intercept, to find an x-intercept, we set the numerator equal to 0. And I get this crazy equation, this untrue statement, 3 equals 0. 3 does not equal 0. So that means I do not have an x-intercept. Sorry, taking a drink real quick. To find the y-intercept, I'm going to plug in 0 for x. That's how we find the y-intercept. Or in other words, find f of 0. So my y-intercept is 3 over negative 4, or 0 comma negative 3/4. To find the vertical asymptote, we set the denominator equal to 0. And so we get x equals 4. Our horizontal asymptote is going to be y equals 0. This is because the degree of the numerator is a 0 and the degree of the denominator is a 1. Anytime your numerator has a smaller degree than your denominator, y equals 0 is your horizontal asymptote. We do not have an oblique asymptote. That only occurs when the degree of the numerator is 1 larger than the degree of the denominator. To graph this, I'm just going to sketch a graph here. Move this down a little bit. This is just going to be a sketch. If you look at the answer key on your review sheet, I've got a better graph for you. So we're just going to sketch this, but like I said, if you look at the answer key, it's going to be better. So we said there was no x-intercept. The y-intercept is 0, negative 3/4. So almost to negative 1, put it about right there. Vertical asymptote, x equals 4. The horizontal asymptote is y equals 0. That is just the x-axis, so maybe I'll make it at a different color so it stands out. Okay, and then that's all the information that we found. We're now going to draw the curves. So I could make this more accurate, and like I said, I did on the answer key. You can see the points, but I know there's got to be a curve down here because I have a point down here, and so I can draw a curve here. My curve is going to approach but not touch across those asymptotes, and I want to make sure that curve goes to the point 0, comma, negative 3/4. There's another curve though. So I've got to figure out what's happening to the right of this vertical asymptote here. So I want to know what's happening over here. So I want to plug in maybe 5 or maybe 6 or maybe 7 or maybe 8. I don't know, something over here to determine what's happening. How about 5? So f of 5 is 3 over 5 minus 4, which is 3 over 1. That means that the point 5, comma 3 is on the graph of f. And so it means that my second curve is up here in the upper right-hand corner. Okay, again, I know this graph looks horrible, so look at your answer key to see a much better graph for this problem. Okay, number 14, finding an inverse function. First thing I'm going to do is I'm going to let f of x be y. Then I'm going to swap the positions of x and y. I take nothing with them. And then now I need to solve for y in its new position. So to solve for y, it is going to involve taking the fifth root of both sides to get rid of that exponent of 5. But before I can do that, I do need to isolate my binomial here to that power. So I'm going to add 2 to both sides. I now have x plus 2 equals y minus 3 to the 5th power. Now I am going to take the 5th root of both sides. The 5th root of x plus 2 is just the 5th root of x plus 2. I can't do anything to simplify that. But on the right-hand side, I just get y minus 3. Taking the 5th root of something raised to the 5th power, it's gonna undo that power. Then lastly, I still want to isolate y, so I'm going to add 3 to both sides. It is typical that you see the 3 in front instead of in the back, just so that there's no confusion about whether it is under the radical. Okay, but it's okay if you want to put it in the back. It's not wrong. All right, so this is our answer. If you want to use the fancy notation, here is how we represent the inverse of f of x. So here is our answer. In WebAssign for this exam, the fancy notation will already be there, so you won't have to worry about typing it in yourself. Number 15 is also an inverse question. It's going to be very similar to what we did in number 14. So first thing I did was I replaced f of x with y. Now I'm going to swap x and y. I have 2 x's, so when I swap those variables, I'm going to have 2 y's. Now I need to solve for y in its new position. So I'm going to multiply both sides of the equation by 2y minus 5. I'm going to distribute on the left-hand side to get 2xy minus 5x. Then if I want to solve for y, I have 2 terms that contain a y. They need to be together on the same side of the equation. I also have 2 terms that do not contain a y, and those also need to be together on the same side. So I'm going to move the 3y over. I'll subtract it. I'm also going to move the 5x over, and I'm going to add it because it's a negative 5x here on the left-hand side. Okay, then we factor the y from the left-hand side. And then lastly, we divide by 2x minus 3. So there is my inverse function. And again, if you would like to use the fancy notation, you are welcome to. In WebAssign, it won't matter because they've already got it typed in for you. So our inverse function is 5x plus 4 over 2x minus 3. Okay, this problem here, this is going to be our last one in this video, and then in the third video, I'll pick up with number 17. So for this one, I do not have to use logarithms. In one coming up, we are going to have to use logarithms. But for this one, I am able to rewrite with a lower base that is common. So I am choosing to use 4, but 2 would work as well. So 64 is 4 to the third. 16 is 4 squared. A power to a power, I multiply those exponents. As I multiply, I am distributing. So I'm taking 3 times 3x, and also 3 times 2, 2 times x, and 2 times -1. Now I can drop those bases, because if the left side equals the right side, and the left side has a base of 4 and the right side has a base of 4, then it would follow that their exponents would also be equal. And then we just solve this. I'm assuming we know how to solve this, an equation of this type, so I'll just do it pretty quickly here. Our answer is x equals -8/7. All right, this ends the second video, and then, like I said, there is a third video, and I will start with number 17. Thanks for watching.